My name is Salman Rashid and my co-author is Shakur Abdul Razak. My paper title is Big Data Challenges in 5G Networks. The outline of this paper is abstract introduction, challenges of 5G, big data challenges, challenges of big data in 5G, conclusion, and finally is references. Nowadays, world is witnessing a huge flood of data due to ever-growing heterogeneous traffic. Mobile network subscribers and online services, this trend is evolving continuously at a rapid pace and diversely in the form of big data. Wide range of use cases scenarios with diverse requirements brings huge challenges for 5G. One of the most important requirements for use cases is high scalability, ubiquitous connectivity with low latency and high data rate with optimal energy are equally important in 5G. Big data analytics is required to process this huge amount of data and extract small size and useful information. This information can be used by arbiters to make consistent decisions. The paper presents challenges of 5G technical scenarios, big data perspective, and emerging technologies of 5G. Characteristics of 5G include extremely low latency, high-speed data transfer, and worldwide connectivity. These characteristics make 5G agile to perform broad set of application scenarios from high user mobility to pervasive video, from ultra-reliable to tactile internet communication, from broadcast-like services to massive Internet of Things, from lifeline communications to broadband access everywhere. For enabling such diverse applications, ruthless improvement in 4G network is required. Currently, during normal operations by management and control functions, a huge amount of data is already generated in 4G networks and expected more to come in 5G network due to heterogeneity in layers. Diversification process and technologies, the additional management and control complexity increases in SDN and NFV architecture. Due to the initiation of Internet of Things and machine-to-machine paradigm, the functionalities and architecture of future 5G networks are expected to be agile in order to accommodate the heterogeneous requirements, latency, reliability, and bandwidth of 5G applications. The expansion of the service scope of cellular networks includes a wide range of services such as mission-critical machine-type communication, Internet of Things, and mobile broadband has evolved towards 5G and beyond systems. To handle vertical services with storage, connectivity, and communication solutions, 5G must be transformed radically. Designed for a precise digital business case of different industries to provide to provide services to users keeping the same cost that user is paying today is set to be a serious challenge for mobile operators and vendors as the expected data traffic is 1000x in the coming era. Wireless industry is facing a strange challenge. It has to improve infrastructure to 1000 times without increasing the capex and opex. Data rate requirements for various applications shown in figures are different in 5G networks. 5G supports variety of use case whereas demand of data rates is also variable in each scenario. Data rate requirements for smart grids for switching windmills on-off and control automation is between 10 kilobits per second to 1.5 megabits per second. For factory automation, where end-to-end data rate requirements are 1 megabits per second for smooth and efficient working. As far as intelligent transport system is concerned, the data rate expected from 5G is between 10 megabits per second to 7000 megabits per second. The reason for such a high data rate is due to its safety and high connectivity with extremely low latency. Healthcare services including tele-diagnosis, telesurgery and tele-rehabilitation, its requirements for data rates is 100 megabits per second with low latency. In near future, robots will be going a lot of jobs such as communication, infrastructure, construction and maintenance in dangerous areas. So the data rate requirements for robotics is 100 megabits per second, whereas serious gaming, virtual reality, and education and culture requirements for data rates is astonishing at 1 gigabits per second. Extremely high data rate requirements is due to its applications in various areas and its sensitivity and high precision of the object manipulation. Latency requirements of various applications are different in 5G networks. 5G support variety of use case, whereas demand of latency is also variable in each case. For factory automation, where end-to-end latency requirements are between 0.25 milliseconds to 10 milliseconds for smooth and efficient working. The latency requirement for robotics is 1 millisecond. Healthcare services include telediagnosis, telesurgery, telerehabilitation. Its requirements for latency is 1 milliseconds to 10 milliseconds. Latency requirements for smart grids for switching, windmills, on-off, and control automation is between 1 milliseconds to 20 milliseconds. As far as intelligent transport system is concerned, the latency expected from 5G is between 10 milliseconds to 100 milliseconds. The reason for such a low latency is due to its safety and high connectivity. Serious gaming virtual reality is at astonishing 1 milliseconds, whereas education and culture requirements are at 5 milliseconds to 10 milliseconds. 5G provides built-in support for device-to-device ad hoc D2D communication, deals local traffic directly and beamforming for reduced interference. For machine-to-machine, 5G can resolve time-critical applications. Architecture of CRAN and SDN relax tight coupling of user plane and control plane. Internet of Things is proliferating exponentially. 5G offers connectivity, connection density, massive data, distinct architectures, multiplexing, extended coverage area, high throughput, extremely low latency, and secure. Internet of Vehicles to accommodate time critical and provide extremely reliable Internet of Vehicles. 5G offers efficient traffic management through small cells for its management with dedicated links. For its computing, 5G offers cloud compatibility to distribute contents, use content-centric networking with extremely low latency, efficiency and agility. In smart cities and grids, 5G provides a much better support in terms of greater spectrum availability, efficiency, longer battery life of its nodes, highly directional antennas, high coverage area, low infrastructure cost, low latency, and huge data rates. To avoid underutilization along with keeping the cost efficiency is the trade-off to rethink. This pose a complex challenges is requirements for infrastructure capacities of 5G networks. Well-designed cost model is required to consider quality of service parameters such as latency, data rate, mobility, jitter, purity, etc. Along with these parameters, cost model should account the features of backhaul and fronthaul links of the network that can influence in cloud and core mobile network. Post-model definition should be able to distinguish between active resources in cloud and distributed mobile core. In service-based 5G, core network deployment and management of network functions are still a big challenge. It is difficult to manage and balance among load and demand in congested urban area for future 5G networks. Management of a network is critical for reliability, service availability, and resiliency of networks. For real-time services, dependencies of entities and network topology evolution is unpredictable in network. The management system must consider the real-time change in topology to identify the fault component and to avoid incorrect and obsolete results. It is difficult to manage highly dynamic networks where service providers might not have full control of the deployment of nodes such as femtocell deployment by end users, active antennas, fluctuating number of node needs, energy saving policies, etc. Due to the complex dependencies and magnitude of tunable parameters, the complexity and large scale of future radio access technologies enforces considerable management and operational challenges. Complex architecture and massive amount of data traveling over a future network, big data in urban areas. Explosion of massive data is no exemption due to a diverse range of connected devices. As big data is growing rapidly in wireless networks, to efficient manage the wireless network, big data analytics is becoming the backbone of the wireless communication. It is not easy to deal with big amount of data, especially if there is a certain goal in mind, since data arrives in fast manners. It is crucial to provide processing speeds, sorting, and fast collection of data. The data distribution is about to change with time. It is challenging to process non-stationary time series data due to the multidimensionality, dynamicity, and complexity of heterogeneous devices with diverse sources and data. It is challenging to develop a computational model or framework that can collect, discover, mine, analysis, and process effective data along with healthcare big data timely and with the best accuracy. To manage and process huge amount of data is challenging in terms of designing of algorithm capable of effective and dynamic processing of resizable data and exploiting inside of data. In business intelligence network is supported to optimize its resources and services to save its cost while providing visibility and flexibility of supply chain and resource allocation. Challenges in business intelligence: a lack of sufficient resources and skilled persons, data integration complexity, privacy issue, and data security, insignificant data warehouse architecture and infrastructure, synchronizing large data. Complexity of big data is challenging in terms of correlation, connectivity of data, and relationship. 5G accommodate variety of services, can handle diverse use cases and future applications that are yet to come. This massive agility and flexibility of 5G brings massive data. The contribution of this paper is summarized in this table that is categorized in terms of characteristics of 5G, its upheld challenges. Challenges in data density are multi-tenancy service-oriented environment extraordinary increased performance expectations, management of cache size, congestion due to huge data, bottleneck shifted towards backhaul and core network, proactive caching framework. Challenges in traffic diversity are diverse requirements, end user quality of experience, and service providers' profit, quality of service level and SLA, performance degradation of path heterogeneity. Challenges in connection density are low power massive connections, congestion due to massive connectivity, high capacity hotspot, small cells may be heavily loaded and new small cells may not be added to the system. Challenges in heterogeneous sources are heterogeneous resources for different slices, diversified key performance indicators, congestion due to huge data, network resource sharing will be achieved in terms of quality of service parameters. Challenges in complex architectures are location-based deployment, complexity of network elements, demands for new use case in design challenges, flexible allocation of resources, small cell may be heavily loaded and new small cell may not be added, end-to-end services in multi-platform 5G environment. Challenges in ultra-low latency are caching redundancy and intra-cache communication. Quality of service requirements are time-bounded. Wireless multimedia services are time-sensitive. Trade-off capacity versus latency, storage versus link load, requirements of ultra-real-time services. Challenges in reliable are reducing CapEx and OpEx, quality of experience of users and resources utilization, management and orchestration of heterogeneous resources, low latency. Challenges in high mobility are resource allocation and network slicing, intelligent mobility in smart cities. Challenges in resilience are detection and location of failures and its performance, handling of anomalies. Challenges in flexible are optimized utilization of the heterogeneous backhaul networks, efficient and flexible orchestration system, network slicing configuration with high accuracy and low price. Challenges in area coverage are seamless wide area coverage. Challenges in scalable are management and deployment of networks scalable at cluster level to overcome potential bottleneck. Radio resource utilization, quality of service parameters, integration of the new management functionality with existing OSS BSS system, scalability of the user plane is neglected, only focus on control plane (VNF) placement. Challenges in secure are security and integrity of SDN NFV environment for function, migration, deployment and implementation of a security system for 5G trust model. Challenges in EMBB are internet service with diverse requirements, mechanism for internet access service, enhanced optimization. In 5G, the intention is move towards meeting the potential of microcells, millimeter wave spectrum, massive MIMO with high data rate requirements. Whereas the goals of 5G networks are handling of big data at low cost, low latency, reliability, scalability, area coverage, and enhanced mobile broadband. To accomplish these goals requires upgraded technologies with intelligent decision making capabilities, cache content delivery protocol, orchestration framework, backward technology support, edge cloud computing, security framework, and newer architecture designs. 5G network will be complex as compared to legacy networks. Apart from its complexity, 5G networks will be smarter and more intelligent in terms of resource distribution, cost of efficiency, load balancing, and network management. Ultra-reliable, low-latency communication are important factors for quality of experience in next-generation communication systems. Thank you.